Hi, welcome to SurvEngCalc Part 6. In this video, I'm going to be discussing a new procedure that I've just added to the SurvEngCalc app. This procedure will calc a full adjustment for a link traverse. When I say a full adjustment, I mean it's going to calculate raw Angles and Misclosure, final whole circle bearing misclosure. The link traverse angle balancing procedure is applied to the whole circle bearings and they're corrected. Partial coordinates are calculated, actual misclosure is calculated, total coordinates are calculated, and Bowditch correction values are then calculated and applied to the total coordinates to give us the final Bowditch corrected coordinates. Okay, right. What we're looking at on screen is a typical link traverse in which the starting station and ending station are known points, i.e. both stations are coordinated and both stations have whole circle bearings to reference objects. The opening station will be a back bearing and for the closing station will be a forward bearing. So basically if north was coming down here, this way here through this station here, the whole circle bearing would be coming off clockwise going around that way. And because we're looking back up, it's going to be the back bearing. And on the final station here, the north line would be coming down here. The whole circle bearing would be coming off the north line to there. And because we're looking up this way, it's going to be a forward bearing. And that's what we need for the app as well. We need a back bearing for the starting station and a forward bearing for the finishing station. And the data that I used is here. Okay, this is the data here. These are the coordinates of station A and station F, and there's the bearings AX and FY. There's AX there and FY there. Okay, and these are all the observed angles going around the traverse itself. Okay, right. Just to say a little bit about this example, I've actually used this example from another video in which I'll leave the link in the description below. Okay. When I did this example, I've done it exactly the same way as what the lecturer did. Now, the lecturer done a really good job of explaining how a link traverse works. I mean, to be honest with you, I do it a little bit differently, but for the sake of students that might use this app, I've done it the way that they've actually laid out. And I do get a few little discrepancies there, but I put that down to me running this through the app and this being more accurate and down to rounding as well. So I mean, there's no rounding in this at all. The only rounding that comes out is the stuff that goes in and the actual output of the coordinates, and that is it. So this will give you a really accurate answer at the end of the day. Okay, right. What we'll do is we go straight into the app. Okay, I'm just going to pull that up, and then I'm going to scroll down to the link traverse there. Okay, pretty straightforward here. Just input the opening and closing station data and press save, basically. So all of this data that you would see here, the opening station and the ending station and the bearings, just goes in here and in here, and you just press save. And all of my procedures on my app, you can press save and call them back up and use them again at another date if you need to. I've already got the data in here, so I'm just going to call it back up. I'm going to go call, and that's the information. That's the information there. So once we've got that into there, we can go to the observed data page. So just press observed data or observed dat on the button there. Go to there. Okay, this is the page where we input all the observed distances and angles. And that's what I'm going to do now. Okay, I'm just going to quickly put one in, and then I'm going to speed the video up a little bit. So I'll just put the first one in. So the first one is 9.260. We got it's going to be 37 and 0. It's a lot difficult to do this on screen with a virtual keyboard, but like I say, after this one, I'll speed the video up a little bit. Okay, and then we press calc. Okay. The information that's been output here is the raw coordinates for each station. and the uncorrected whole circle bearing data. Okay, so basically what you've got there is as we go through it, you'll have the raw coordinates for each station and the unadjusted whole circle bearings for going in between the lines there. Okay. Okay, now we're on the final observation, which is the closing angle. So basically it's the last angle and the last observation, which is here. This is the 173.31.0. So I'm just going to quickly plug this in. 0. Okay, that. And then I'm just going to press calc. Okay. From the closing angle, we get the final uncorrected whole circle bearing, which is this here, which it doesn't match the known reference object whole circle bearing at station 6. So the reference object whole circle bearing at station 6 is this bearing here. Okay, so this is basically because of an accumulation of errors within the observed angles. That's built up, but that's been put through to the whole circle bearings, which ends up here. Okay. If you can recognise this and you sort of like know what you're doing, then there's a little procedure that if you was number crunching these through a calculator, where you can actually skip the angle balancing procedure, because basically this is going to be the same value as the value that you've got to apply to the angles anyway. So all you'd have to do is basically subtract your this whole circle bearing here from this whole circle bearing here, and that will tell you what the area is anyway. And then you just spread that through the 6 observed angles. But it's not really done like that, and I've actually done it the way it was shown to done in the example that I've left the link to. So it's just something to bear in mind. Okay, so when we get this last whole circle bearing output here, we get a little green button. This is the misclosure button, which calculates the errors and adjustments. So if I just press that now, so basically at station 6, this is what I've just discussed here. The observed whole circle bearing and the reference object whole circle bearing, there's a difference of 2 minutes. Okay, and the raw misclosure in eastings and the raw misclosure in northings are from the raw coordinates at 6, where we've just come through and got raw coordinates for they're completely unadjusted. So that just gives you a rough idea of what it is. Now we're coming on to the angle balancing procedure here, which is all done in the app, but I'll just explain how it's done. So the sum of the observed angles comes to this value here, and from the angle balancing procedure, which I'm not going to go through, if you go to the video that I recommended with the link that I put down below, the lecturer will explain to you how you get this value here from balancing the angles. Okay, but this is what the theoretical angle value is, and this is what our observed angles should have hopefully have come to, but they don't. So we've got an angular error there of 2 minutes. Now if you look at that, it's exactly the same. This is what I was talking about. Okay, there. But this is gained from balancing the angles, and this is gained from just working the coordinates in bearings and distances around, and giving yourself coordinates and bearings until you get to the end there. It's exactly the same. It's the accumulation of error. Okay. But anyway, this is the angular error. Okay. So what we've got to do is divide that between the 6 stations, and that gives us a value of 20 seconds to be added to each angle, each one of the observed angles, to make this value here equal this value here, and then we balance the angles. Okay, and the reason why we've got to add it is because this is a negative value. If it's negative, we have to add it. If it was a positive, then we would have had to subtract it. Uh, anyway, that's basically what that little bit is there. And what what we're going to do now is uh, right at the same time as when this is printed out here, we get a little yellow button appear on the top right hand corner there. Okay, so we're going to press this to see all the applied adjustments and the final Bowditch corrected coordinates. It's as quick as that. So if I just go here, print this, okay, what we've got here is our observed angles and our observed distances here. I've decided to put them in there so you can just check them off to make sure you put them all in right. Okay, and then what we've done is we've adjusted the angles using the angle balancing procedure, which is within the app. And now the sum of these angles here, the adjusted angles, is this value here, which, surprise, surprise, matches this value here now, the theoretical angle, which was gained from the angle balancing procedure. So now we've adjusted the angles, we can correct the whole circle bearings. Okay, so now when we get to the last whole circle bearing at 6, we can see that this now matches the end whole circle bearing, the reference object whole circle bearing there. So we now know that this is correct. These are all correct. Okay. And then what the app will do is it will calculate the partial coordinates for you. And from the partial coordinates, we can get the true misclosure in east ends and the true misclosure in north ends. Okay. This is the proportional error or the accuracy, if you like. And then once we've got the partial coordinates, we can work out the total coordinates. Okay, we get the total coordinates, and then we can, from the misclosure in east ends and north ends, we can work out the Bowditch correction values, which are these values here for each stations, east ends and north ends, and then we can apply those to the total coordinates to give us the Bowditch corrected coordinates. And basically, that is the calculations in a nutshell. So that's everything. Okay. There's one little thing I've got to tell you here, and I've got to stress as well. Before you leave this page, you have to make sure that you copy any relevant data, because if you don't, once you press this and go back, there's no way back in. And so what I've done is I've just put a little thing on here. When you go to here, you press this. It'll ask you if you copied any data. If you say no, I haven't, then it'll stop you there, and then you can go back and you can copy the data. So you're going to copy it, then you're going to use your device share function to send it out. Send it to whatever. You can email it, you can text it, or the best thing I do is store it to Google Drive in Google Docs. I'll use it there and just download it from there. But yeah, so make sure you copy that, because once you go out, that's it. So once I press this here, and I say yes, that means yes, I don't really want to copy the data, and I've just wanted to look at it, or yes, I've copied the data, go there, and that's it. That button's gone now, because the calculations are all done on this button, and if you used to press it again, then the new set of calculations get worked out, and it just jumbles them all up on the print page. So for now, if I wanted the data again, I'd have to completely shut down the app, SurvEngCalc app, to reset it, relaunch the app, go into link traverse, call up the save stations, then re-input the data, and that, folks, is it. So thank you very much.